Okay, so what we're going to do here is going to combine two things. We're going to use the unit circle and some of the trig ratios which we discussed earlier to answer the following problem. Okay, we're told that theta equals 3/4 pi, find cos theta, sine theta and tan theta, and we're going to do it without a calculator. We're going to use the unit circle effectively and some of the trig ratios. Now, first of all, because it's to do with quarters here, we've got 3/4 effectively. Automatically, you should think to yourself, well, what kind of cosines, tans, and so on do I know that involves quarters? Well, if you go back to a previous clip, if you remember, we had the isosceles right angle triangle, which was 1, 1, root 2, and we had pi over 4, or a quarter of a pi here, which is 45 degrees, and pi over 4 here. If you remember the rules from that, this problem is going to be something to do with that triangle, okay? Because it's something to do with quarters, so it's going to have something involving this, because we've got quarter of pi in the corners here, and we've got 3/4 here. Now, let's draw a unit circle first of all. Okay, so let me draw my axes. Okay, here's my x and y. Okay, and here is the unit circle. Right, first of all, it tells us that the angle is 3/4 pi. Let's try and figure out where that is. Actually, you know what, let me draw that circle a little bit bigger so we can see where that is. Okay, so this would be 0 degrees pi, this would be pi over 2, this would be pi, and this would be 3 pi over 2. Okay, so the angle's 3/4 pi. Well, that means it's going to be somewhere in this region here. That's a half a pi, and this is a full pi degrees, so radians. So it's going to be somewhere over here. So the angle, oops, it must be. Let me start from the origin. Okay, it must be something like this. That must be 3 pi over 4. Okay, and then we're effectively trying to find this coordinate, aren't we? You know, the cos theta and the sine theta part. We're trying to find that particular coordinate. But the thing is, though, it's kind of difficult to do it with a 3 pi over 4. So what we need to do is try and make a right-angled triangle somehow. And maybe something that looks a bit like this, maybe, okay, with a quarter pi's. And then we can sort of try and figure out what cos theta and sine theta and tan theta is. And really, you know, cos theta and sine theta, that's the actual coordinate part here. Cos theta is the x component, sine theta is the y component, right? We're going to try and find that out. Now, here's a triangle I can make. Here's a right angle triangle I can make. I can make one by going down here. That'll be the right angle. Okay, and yeah, I mean, we could use the all silly turtles crawl, but really, we're going to just do it by brute force. We're going to work it out, and we're not going to use the ASTC. We're just going to do it by this particular triangle here. Now, if that's 3/4 pi, then what's this angle here got to be? What's that angle got to be here, this little one here? Well, if that's a whole pi and that's 3/4 pi, this must be pi over 4. Right, that must be pi over 4. Let me draw that triangle a little bit bigger here. So, this is remember, it's a unit circle, so that length is 1, and then this would be pi over 4, right? And this would be the right angle, right? Okay, and we're trying to effectively find this particular coordinate, because the angle theta is this one here, right? We're trying to find that coordinate. So to find that coordinate, we need to know this distance, and that will be the x component, and then we need to know this distance as well, and that'll be the y component, right? Now, if you recall, okay, there's your pi over 4 now. Here, look, pi over 4, pi over 4. So we need to try and find this particular length here, okay? And if you use SOHCAHTOA, right, SOHCAHTOA tells us that, well, this is the angle of interest. Let me do it in a different color. This is the angle of interest. This is your opposite. This is your adjacent. And this is your hypotenuse. Well, we're trying to find the adjacent, and we've got the hypotenuse. So this is going to be cos pi over 4, which is the angle. But that equals the opposite. So that equals the adjacent divided by the hypotenuse. Well, the adjacent divided by 1 is just the adjacent, so that's cos pi over 4. But if you go back to the clip where we discussed this right angle triangle here, we actually know what cos pi over 4 is exactly. It's 1 over root 2 based on this triangle here. It's 1 divided by root 2. That's the identity we got from this. Cos pi over 4 is 1 over root 2. So this distance here must be 1 over root 2. But if you think about it in terms of this context here, we're trying to find this coordinate here. So that's 1 over root 2. But the thing is though, if I start at the origin and I'm going to go left to this spot here to then go up, I need to be going a negative number this way, right? Because the negative number is this side. So that must mean that this, even though the distance, the length is 1 over root 2, this particular spot must be minus 1 over root 2. So we've worked out one component already, that cos theta, this large angle, cos of this large angle, must be minus 1 over root 2, right? It must be minus 1 over root 2. Right, now we need to go up from this, so we need to work out this vertical distance here. So we're trying to find the opposite now. Opposite over hypotenuse, so sine of pi over 4 is going to be the opposite divided by the hypotenuse, which is 1. I could write it over 1, but the opposite over 1 is just the opposite. So sine pi over 4. But based on this triangle, we already actually know what sine pi over 4 is. Sine pi over 4, we discussed earlier, is actually 1 over root 2. So this distance here must be 1 over root 2. But the thing about it is that it's going to be a positive. Yeah, this is definitely going to be positive, because if we go up, we need to go a positive number. So this must be 1 over root 2 up. So that means that sine of the actual angle theta must be 1 over root 2. So we've actually worked out, okay, if we sum this up, that cos of the angle 3 pi over 4 is got to be minus 1 over root 2, and then sine of 3 pi over 4 must be 1 over root 2. Okay, because that's the particular coordinate we have. We've got to go minus 1 over root 2 here and up 1 over root 2. So these have to be the numbers, right? But we're just using pi over 4 to actually work out these numbers here. Right, all that's left is to work out tan. Okay, tan. Now, remember, when we got these two, we divide that one by that one to work out tan. So let's do it that way. Tan 3 pi over 4 equals sine 3 pi over 4 divided by cos 3 pi over 4. So what we're going to do is we're going to do 1 over root 2 divided by minus 1 over root 2. Oops, minus 1 over root 2. But if you think about what we have here, is we have 1 over root 2 divided by almost by itself, but minus itself. So that's just going to be minus 1. Okay, it's just something divided by itself is 1, but something divided by minus of itself is going to be minus 1. So tan, let's finish it off, tan 3 pi over 4 has to be minus 1. So without the calculator, using a trig ratio that we know from before, we've worked out what cos, sine and tan of 3/4 pi is without a calculator. It's got to be minus 1 over root 2 for cos, and 1 over root 2 for sine, and minus 1 for tan. Alright, let's tackle one more. Okay, so we have that theta equals 4/3 pi. And we're going to try and find cos, sine and tan. Now, again, we're dealing with thirds of pi, so think about the triangle we discussed before. If you recall, we had the half of the equilateral triangle like this. We had 2 here, 1 here, we had root 3, and then the angle in the corner was pi over 3, right? Okay, it was 60 degrees pi over 3. And that was pi over 6, but we're not going to use that top angle, we're just going to use this bottom angle, right? So we're going to use some of the ratios based on this. Now, let's draw our unit circle and try and figure out where that particular angle is. Okay, so here's our axes. Let me try and draw a big circle, try and make it centered there. Okay, that's pretty good. 0 degrees radian, pi over 2. That's just pi, and this is 3 pi over 2 is here, right? Now, if you think about this number here, it's 4/3 pi. Well, 4/3 is an improper fraction, so it's 1 and 1/3 really. So it's going to be bigger than pi, but less than 3 over 2 pi, right? So it's going to be, the angle is going to be somewhere down here, right? Somewhere over here. It's going to be somewhere over here. Now, if you think about what we have is this. We're going to do the same thing. We're trying to make a right angle triangle. We're going to try and find out this particular chord. Remember, cos theta is the x component, sine theta is the y component, and when you divide that one by that one, we get tan. So we're trying to make a right angle triangle at this, and we know what particular signs, the particular answers we're going to have. Tan is the only one that's positive here, so these two are going to be negative answers, right? And if you think about it, it's going to make sense. If you start at 0, you're going to go negative that way and negative down to get this point here. Right, let's try and make a right angle triangle. So let's go up and across. Okay, so we've got a right angle triangle like this. So this is the purple bit here, and then you've got the yellow line going like this. Okay, there's a right angle, that's the length of 1. Right, so what's this angle got to be here? Well, if you think about it, this large yellow angle is 4/3 pi, and then this bit's pi, right? So we need to just do 4/3 pi, take away a whole pi, and see what's left. Well, we're left with pi over 3. So this angle's got to be, you know what, this is really, really small, isn't it? This angle's got to be pi over 3. Okay, and so if we use a bit of trig, this is our angle of interest, this is the opposite, this is the adjacent, this is the hypotenuse. SOHCAHTOA. Okay, let's work out the adjacent first, see how much we're going to go along. Alright, and the adjacent is going to be cos, okay, so it's going to be cos pi over 3, which is the adjacent, divided by the hypotenuse, which is 1, so that's just going to give us the adjacent. Right, so cos pi over 3. Now, if we go back to our identities, cos pi over 3, okay, cos pi over 3 was a half. Okay, cos pi over 3 was a half, right? It was the adjacent divided by a hypotenuse here. So, so this distance is going to be a half. Now, that's the length. It's going to be, that's just a half. But if you think about it in terms of the context of the problem, if we start at the origin, this distance is a half, but this particular point is going to be at minus a half. So that means that cos of 4 pi over 3 is going to be minus a half, alright? Because it's going to take us to here. And then, right, let's work out the opposite now. So to work out the opposite, okay, let me do it in a different color. Let me do it in yellow. Opposite over hypotenuse, we're going to use sine. So sine of pi over 3 is going to be the opposite divided by the hypotenuse, or opposite divided by 1 in that case, but that's just going to be the opposite. Right, pi over 3, sine pi over 3, right. Based on our trig ratios from before, we know what sine pi over 3 is going to be. That's going to be root 3 over 2. Okay, root 3 over 2, this, we've discussed that. But if you think about it in terms of the context of the problem, alright, this distance is root 3 over 2, but we're trying to get down here to this particular value, so that means that sine 4 pi over 3 must be minus root 3 over 2. Okay, because we're trying to get to this point here, which is going to be well, if that's the length is root 3 over 2, then then to get down here, that point there must be minus root 3 over 2. Okay, remember it's the coordinates, so we're going minus a half long and then minus root 3 over 2. Now all that's left is to work out what tan is going to be, right? Tan is going to be that one divided by that one, so we're going to do, tan of 4 pi over 3 is going to be minus root 3 over 2 divided by minus a half. Okay, so remember, well, it's 2 minuses make a plus, so remember, okay, that's what we discussed, that only tan is going to be positive, so we got that already. So root 3 over 2, change it to a times, flip the other one, 2 over 1, right, well, the 2's cancel out, and we're just left with root 3 over 1, which is just root 3, so tan of 4 pi over 3 is going to be just root 3. And that's it.